Welcome pre-kindergarten and kindergarten students to the Dallas Independent School District's STEM Environmental Education Center. We'd like to give a special welcome to a number of schools who are with us this morning. We have students from W.A. Blair Elementary with us this morning, students from the Dealey Montessori and International Academy with us, students from David G. Burnett, and students from the Solar Preparatory School for Girls. Thank you so much for joining us this morning. We wish you could be here in person. But since you can't be here in person, we're going to do our best to make you feel like you're here doing our virtual field trip this morning with us. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/EEC register to get yourself or your class registered for this field trip. We just use that information for our attendance purposes. And this morning's field trip is going to be about properties of water. During this virtual field trip, students will discover that the natural world includes earth materials. Students will observe and describe physical properties of natural sources of water, including color and clarity. So we're going to start off this morning by exploring different natural sources of water with Ms. Nash. Next, we're going to explore color and clarity of water with Mr. Monroe. Third, you're going to see an egg investigation with Dr. Gorman. And last, you're going to see a drops of water investigation with me. While we're doing all of that, you can ask us questions, and we encourage you to ask questions. Since this is a virtual field trip, the way you ask a question is you'll go to www.tiny.cc/EEC-question-answer. And once you'll get there, you'll fill out a very short form to ask us any questions you have related to properties of water. You can ask as many questions as you like, and we'll do our best to answer all of them in the time that we have with you this morning. So let's get started with this trip. Let me stop sharing my screen here and turn it over to Ms. Nash, who is going to get us started with natural sources of water.
Good morning. Welcome to my classroom. So yesterday it snowed. Did you see snow at your house out the window? Or maybe you went out to run around in it. At my house it fell. It was beautiful, so beautiful, but it melted. It didn't stay, but it was still really amazing. And that's where all our water starts. Falling from the sky, either snow like we saw yesterday or rain more commonly. So when it falls down, show me how that rain fell, the snow, and it was kind of floating down. And when it falls to the ground, it can soak into the ground and the plant can take up the water, or it can make a puddle. Un charco. Can you say puddle? A puddle. Un charco. A little bit of water. And in that puddle, we might find a tadpole, a little bug insecto, a puddle duck, un patito. And then if there's more rain, that puddle can get bigger and bigger, and it can become a pond, una laguna. And in that pond, you might have a pond at your school. It might have goldfish or koi in it. But a pond like we have out here has frogs in it. The birds come to hunt little fish, has little fish in it. Okay. So a pond. So we've got the drop of water, the puddle, and now the pond. Things are getting bigger. As more and more water accumulates or piles up, more and more water. And then we have rivers run in and they make a lake, un lago. So in a lake, we might have a snapping turtle, an otter, a gar, a water snake, or a rainbow trout. A lake, say lake and lago. And then more and more water from all the big, big rivers, and it makes our ocean. So our ocean is kind of the most amazing thing about our planet. Most of our planet is an ocean, okay? One giant ocean. And in that ocean, the oceano, we might have whales, whale sharks, a sea turtle, a seahorse, an octopus, an eel, and this one, the oarfish. Isn't that cool? So many different kinds of animals that live in different bodies of water, different kinds of water. So if you were here with us, we would go out for a walk and we would see what we could find in the way of natural sources of water or places we can find water. So I'm going to share my screen because I took a walk the other day right out here and I took some pictures of what I found. Let's see what I found. So this is from yesterday. I took a picture out my window at home, but I couldn't really get the, that's the snow falling through a window. You can't really see it falling, but it was falling. It really was. It was so beautiful. I went out for a walk in it. But then it made puddles. See how it was on the leaves of the plant there? All those drops. See the drops of water? And they all get together and they make a little puddle. There's a little puddle on my patio. Now here, when I went out for my walk here on Friday, it was a cloudy day and you can see that in those clouds, there's rain in those clouds. Water is condensed, it made a cloud. Lots and lots of drops of water. And sooner or later, they're gonna fall out. And here's a puddle. There's a puddle at our place. Now that puddle didn't come from rain. That puddle came because our windmill is pumping water from underground. Some water, when it falls, it doesn't go in a puddle or a pond or a lake or a river or the ocean. It goes down through the ground, underground. And we can use a windmill or dig a well to get that water out. And you can see that hose taking the water to that little tank there to let our animals have some water. And so much water went in and it ran out. That was that puddle that we saw. That's where that puddle came from. It came from that little water trough. Now I walked on and I found a pond, La Laguna. And the pond is not very big. You might have an even smaller pond than this at your house or at the school, a fish pond. This is our little pond, and it filled up with rain. It had been almost dry, but then it rained pretty much, and it filled back up. You see the edges there, muddy along the edge, and it's going down. So see that white line on the edge? That's where it was, but now it's going back down. And then I walked onto our big lake, or it's a small lake, but it is a lake. And it has even more water. And this one dried up completely, earlier. So there's our lake, a lake. Here's what it looked like earlier this year. See, no water at all, completely dried. So what do you think happened to all the animals that lived in that lake? They either had to go somewhere else or they all died. So pretty interesting, to think about where our water comes from. I'm gonna stop sharing now. And I'm going to ask you to stand up and let's review our bodies of water. So put your arms out wide like the ocean. The ocean's all around the world, all around the ocean. And we have the lake, the pond, the puddle, the drop. Lago Tita, El Chaco, La Laguna, El Lago, El Océano. And where did it all come from? It came from the cloud and the raindrops fell all the way down, all the way down. So say it with me, all the rain goes down, down, down. Take care of lluvia. So thank you for your attention. And if you have any questions, you can ask Mr. Broughton today. There it is. So bye.
Thank you, Ms. Nash. The question that came in was, are there natural sources of water underground? And yes, there are. And those are called aquifers, which we do have in Texas and where a lot of our drinking water does come from. So we have water in the sky that can fall as rain, water on land in lakes and puddles, and even water underground. All right, now we are going to look at color and clarity of water with Mr. Monroe.
Good morning, students. My name is Mr. Monroe, and we are going to investigate water, its color, and the clarity. Clarity means how clear it is. You know, water is essential to life. The primary use for water, we drink it, right? Let me ask you this. Would you drink water from this glass or would you drink it from this glass? Which would you prefer to drink water from? I would imagine you would pick this one, right? Because this one is not looking so good. You know, pure water, I guess it's really clear. Let me go ahead and show you that this water that I'm going to drink is safe. Very good. And you know, water is important for us to drink because it is a life essential. Now, I don't dare drink this because I know that it is not even close to being clear. Pure water sometimes can be not clear. It can have just a little bluish tint to it. You know, sediment, that means little tiny bits and pieces can be in water. And the water that we're using in our everyday lives, that water has been filtered and it has been cleared up. Okay? Now, Ms. Nash talked about several sources of water. The primary source of our water, guess what? It's when it falls from the sky like she showed you. And then it falls into places where it can be stored. Now, I have some water samples here that I want to show you. In fact, she showed you our pond. Now, that water in the pond is not going to look as clear as the water that I was drinking. In fact, this is a sample of the water from the pond. It's in a scientific container called a flask. And if you look at it, and it's got some stuff floating around in it. And when there's some matter or objects floating around it, we say that those matters are suspended. In this case, we have something called green algae, which grows in plants. And we know that this surely wouldn't be good to drink, right? I have another flask here, and you heard Mr. Broughton talk about an aquifer. Well, we have the windmill, which Ms. Nash showed you, and actually that windmill acts as a pump using the wind's energy to turn the blades to bring water up from underneath the surface of our planet. Oh, I think it's about 30 feet underneath. And you know what? It's amazing. There's a puddle or a big part of water that is stored in an aquifer that's trapped in between rocks. And believe it or not, when that water comes up from that well, it's just as clear as the water that I was drinking. Now, most of the time, water can be the color of what's in it. For example, there's a river that separates Texas and Oklahoma, my home state. And you know what they call that river? They call it the Red River. And if you look at the water that's in it, guess what? It does have a reddish brown color to it. You know why it has that reddish brown color? It's not because of maybe the sunlight shining on it and making it red or anything like that. And I'm going to be talking about that a little later. But it's because of the soil that is around, or it lines each side of that river. Here I have the water. Believe it or not, this is some real red soil coming from the state of Oklahoma. And I'm going to put a little bit of this in there, and we can see what happens to the water. It's a reddish brown. We can see why they call the river that runs between Texas and Oklahoma, they call it the Red River, because the water that is flowing in that riverbed, moving on down the river, it's picking up some of the soil that is along the sides of it and even running into it from rainfall, pushing it in, and it's a reddish brown. Now, you know, I've heard students ask, why is the ocean blue? Well, if you really think about it, the light that shines on us, the light that we use to see things with, the way that we see things, light has to reflect off of the object so that we can see it. And basically, a lot of people believe that our oceans are blue simply because the light in the sky is reflecting the color of the sky into the water. That's almost correct. You guys ever seen a rainbow? And we know that a rainbow is basically sunlight shining through the water droplets falling from from the clouds. And those raindrops are actually separating the natural light from the sun into the basic colors of light: red, orange, yellow, green, blue, indigo, and violet. Well, guess what? When the sunlight is shining into the ocean, it's being broken down to its basic colors. Actually, red, orange, yellow, green, those wavelengths of light, guess what? They're being absorbed by parts of the water that we call molecules, little tiny particles of water that we call molecules. But the colors blue, indigo, and violet, they kind of mix together and they give the ocean a blue color. And you know what else, guys? If you go real deep into the ocean, guess what? That blue color is going to change into dark black, simply because the further you go down, the less sunlight you have. So I hope you kind of understand about the colors of some water. Next, I want to talk about clarity, clearness. There's a big word that we use when the older students come out here and we're testing the clarity of the water. We use the word turbidity. And turbidity means the clearness. Going back to the pond water, we know that that's not very clear simply because there is a lot of that algae floating around. We know that this water that I put the red soil into that came from Oklahoma, we know that some of the particles of that soil are floating around in there. We call those suspended particles, and it makes the water kind of unclear. And that means sunlight is not going to be penetrating it, right? Not like it would be if the water was clear. So a lot of times, plants need sunlight, don't they? A lot of times on the bottom of places where the water is not so clear, you can't get any plants to grow. We know that plants are very important, right? Water plants. I guess the best way I can kind of show that, I have what we call a sedimentary tube here, or sediment tube. At the very bottom of this, we see there's gravel. I don't know whether you guys can see that. Then it gets into sand. And then we get into a little bit of silt, real fine particles. And if you look, the water is dirty brown. And what that means is suspended particles are floating around in that. And we know that could have effect on fish too. Fish have these slits in the side of their heads called gills. And that's how they take in oxygen, air to breathe. And they swim in the water. And as they swim through the water, water passes through those gills and they get the oxygen from the water. Do you know, because of particles floating around in that water, it might have a big effect on that little fish's ability to breathe oxygen from the water. Listen, there's an instrument we use to measure how clear the water is. For example, this is a turbidity tube. If you look down the center of this tube, if I could get that to you, you see a black and white design, right? Well, I'm going to pour some of this Red River water into it. Now, we saw that black and white design, didn't we? Well, I'm looking down in there now, and you know what, guys? I don't think you can see that black and white design now because the water is dirty water. It's not very clear. So that's what clarity means, the clearness or the turbidness of the water. Now, hopefully you kind of understood a little bit of what I'm talking about, colors of water, clarity of water. And if any of you have any questions, I'm going to turn it back over to Mr. Broughton, so maybe he can answer those questions for you. All right, Mr. Broughton.
Thank you, Mr. Monroe. The question that came in was, how many different colors can water be? And water can actually be lots of different colors because of what's in it. So for example, water can be red or green or yellow because of a microscopic organism called algae that's living in it, and it'll make the water appear to be those different colors. Pure water will be clear, but if there's other things in it like algae, it can be lots of different colors. All right, now we're going to see the egg investigation with Dr. Gorman.
Your video back? No, you're good. Just wait for it. There might be a lag time. No, your video doesn't play. What's wrong with your computer?
We can see and hear you.
Oh. What? They can see you.
Okay.
Just go ahead and go.
Okay. Good morning. Sorry about that delay. My name is Dr. Gorman, and my able assistant here that helped me with this experiment is Lauren the chicken. She went to the trouble of laying 2 eggs for us so we could do this experiment this morning. So we'll say thank you, Lauren. We couldn't do without her. During this experiment this morning, we're going to introduce 3 very big scientific words. I know they're a little bit above your head, but all throughout your science career in high school and college, you will be hearing these words, especially the very first one. The first one is hypothesis. You're going to do a scientific guess when you make a hypothesis. All it is just a guess. So whenever somebody says, what's your hypothesis? You tell them what you think. And that is the word that I want you to remember from this lesson for sure this morning is hypothesis. The second word is density. And density, breaking it down, is just the amount of something that you can put in a given volume. We're going to use water this morning. 1 cubic centimeter of water weighs about 1 milliliter. And the last word is buoyancy. Now that's a real good word. It means the ability to float. If I go out in my backyard and jump in my swimming pool, I don't have much buoyancy. I tend to go straight to the bottom. On the other hand, my wife can get out there and get in the pool, and all she has to do is just splash around a little bit every once in a while, and she floats very well. She is very buoyant, and I'm not. Now, the materials that we're going to use this morning in this experiment of will an egg float or will it sink? And we're going to use 2 brown eggs right here. Get them out, try not to break them. I'm just going to show you one of them. We're going to use 2 brown eggs. We're going to use 2 glass containers so that you can see them. What we're using is 500 milliliter beakers. They call them a beaker because it looks like a bird's beak. At least that's what my chemistry teacher told me a long time ago. So I've always believed that. To me, it looks like it should be a half beaker, but they didn't ask me. We're going to have some water. We're going to use quite a bit of water. We have 2 containers of water. We're going to use some salt. We're going to use some tongs to handle the eggs with. You'll use these a lot in your science career throughout high school. And we're going to have a stirring device. Now, what the stirring device is a spoon. They make some fancy stirring rods and this, that, and the other, but we're not going to use them. We're going to use just a plain old spoon. Okay, our procedure is we're going to fill 1 container 3/4 of the way full of water. We're going to put about 400 milliliters of water in this glass beaker. All right. Now you make your hypothesis, make your guess. If I put this egg in this beaker with water in it, is this egg going to float or is it going to sink? You make your hypothesis because I'm fixing to not drop it, but gently put it in here. And what did it do? It went straight to the bottom. So that means that it will, this is fresh water. This is just like you got out of the faucet at your house or at your school. There's nothing special about it. Now, was your hypothesis correct or was it incorrect? Did you guess that the egg would sink or did you guess that the egg would float? Now, in this case, the egg went to the bottom. So the density was more than the density of water. So 1 cubic centimeter of this egg weighed more than 1 cubic centimeter of water. Now we're going to do the same thing with another beaker. We're going to put about 400 milliliters of water in it. You may have to steal some water from the other container. Yes, we will. Now we're going to stir in about 6 tablespoons of salt. We're going to make it like ocean water. If you've ever been to the ocean, I know that you've got some water in your mouth, and that is the saltiest thing in the world. And about 2 or 3 days later, you're still going to be trying to get enough water to get that salt out of your mouth. Just a second, I'll tell you a story about my experiment with it. We're going to use our scientific stirring device. Remember, it is a simple spoon. Now, once a long time ago, I was a search and rescue air crewman in a helicopter for the Navy, and we had to go out and make some overwater rescues. And we wore gear, and we had a helmet, a mask that we put on top of our head, and we held it there. We didn't jump in the water with it on because sometimes it would break and get in your eye. So you would hold it in place. Well, I forgot to hold it. And I jumped in the water from about 25 feet out of the helicopter. And when I started going under, I realized I didn't have my mask on. So I reached up to grab it, but I went, oh! And when I did, I sucked in about half of the Pacific Ocean. And about 3 days later, I was still had a salty mouth, and I was still trying to figure out how to get that taste out of my mouth. After that, I always made sure I held that mask in place with my hand when I jumped in. Now we're going to put this in the water. You're going to make your hypothesis. Will it sink or will it float? Let's see what happens. Okay, you can't see it very well, but I can see it perfectly. It is bobbing around in the water. I'm going to put this behind it and hold it over to the side so maybe you can see. Maybe you can see that that egg is floating, it's not sinking. So that means the density of the salt water is more than the density of the egg. Were you correct or were you wrong? All right, we're going to go over the vocabulary words again right quick to finish this lesson up. Hypothesis is your educated guess what's going to happen. If you don't get it right, it's okay because you still proved or disproved the theory. We can still use that information later. Density is the amount of a substance in a given volume. Remember, we used water, 1 cubic centimeter, 1 milliliter of water in 1 cubic centimeter of space. and buoyancy, the ability to float. Go out and jump in your swimming pool when weather gets better, and see if you tend to sink or float. Do you have buoyancy? Okay, right now we're going to turn this over to Mr. Broughton. If you have any questions, please ask him. Thank you for joining Lauren and I today. And the next time you eat Kentucky Fried Chicken, just remember Lauren is not there. She is still out.
Thank you, Dr. Gorman. The question that came in was, what things will sink and float in salt water? And that will be an excellent challenge question for you. I don't want to give anything away because you could do an investigation with freshwater and with salt water to see what things sink or float in each. And it would be a really good science experiment for you to do at school or at home. And now we're going to move into another science experiment. So I need to just share my screen here and pair up my iPad with the computer, which should just take a second. I think we're almost there. There we go. So you can see here, I've got a penny sitting on a little notepad here, a beaker of water behind that, and a dropper. And my question is, how many drops of water will fit on that penny? And before I get started with actually doing that, I'm going to show you too, one other thing I'm going to use here is my science notebook. I'm going to record all of my data here in a science notebook where I've got different coins, so I can try a penny, a quarter, a dime, and a nickel. And before I actually find out, I'm going to predict how many drops I think. So for that penny, I measured the length of that penny with this ruler, and it is about 2 centimeters long, which is also 20 millimeters. And I know a drop is pretty small, like a millimeter. So I'm going to predict for that penny that it will be 20 drops of water is my prediction. So there I recorded that. And now let's actually find out how many drops of water fit on a penny. So I'm going to zoom this in here. Try to get that centered in the screen as best I can. And I'm going to suck up some water with my dropper and start dropping it on the penny. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, and there it just finally leaked off. So 21 is what fit because the 22nd one fell off. So let me take that penny off and record in my notebook that it was 21 drops. Let me zoom back out here. And so I was actually pretty close. There. So 21 dropped. My prediction was 20. The actual was 21. That's not too bad. All right, now let's try the quarter. And since I predicted 20 for the penny, but the actual was 21, a quarter is about 25 millimeters long. So maybe I should predict 26 for the quarter. Like that. We'll see. So let me get my quarter up here. And zoom in on that too so we can see it better. And I'll get some water in my dropper here. Let's see how many drops of water fit on a quarter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Oh, and then it went. So I'm going to say 28. So again, I was pretty close. Yeah, bring that back. And there we go. Now let's try the dime. So let me take my quarter off here. I should have used something besides a piece of paper because it's just getting so wet underneath. Well, I'll just turn that around that way. Now a dime, if you look at a dime, it's almost the same size as a penny, but it is actually a little bit smaller. Like if I put them right over the top of the other, you can see the penny is just a little bit bigger than the dime. So I predicted 20 drops for the penny and the actual is 21. Maybe I'll predict 18 for the dime because it is a little bit smaller. So there's my prediction. And now let's find out how many drops of water will actually fit on this dime here. So let me get some drops again. And there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. Wow. That was a lot more than I predicted. So if I zoom back out here, somehow, even though that dime was smaller, it was able to hold more drops than the penny, which actually leads me to a couple of challenge questions for you. Is one, I'm going to let you do the nickel by yourself. And we know a nickel is bigger than a penny, but smaller than a quarter. So what prediction would you make for that nickel? And then actually try it if you can find a nickel. And another challenge question would be, why did that dime hold more than the penny? And then a third question, a challenge question would be, is if I repeated this whole investigation all over again, would I get the same results? Like when I did the penny the first time, I got 21 drops. Do you think I would get 21 drops if I tried it again? Or if I tried the quarter again, when I get 28 drops again? Or if I tried the dime again, when I get 23 drops again, over and over again? It'd be interesting to try it multiple times to see if you could actually get the same totals again and again. But I'm going to let you do that because I think it would be interesting for you to find out without me telling you all the answers for that investigation. That's an investigation that I'm sure you could do at home. All you need is a dropper, the coins, and some water. And a notebook or even just any piece of paper to record your information. So the question that came up was, why do I record information in a notebook when I do an investigation? That's so that I can remember what happened during the investigation. By tomorrow, so many things are going to have happened. I might not remember how many drops of water were on that penny, but if I write it down and I forget, then I can just go back to my notebook and look again. Also, scientists like to compare information with each other, and the way they can do that is by sending each other their data so that they could say, okay, I did this investigation and I got these results. I'm going to send them to you and you do it and see if you get the same results. Because if everybody is getting the same results, that must mean that it's correct. If everyone's getting different results, there must be something else going on and maybe it's not correct. But that we've got to record your information in order to share it with others, so that they can see what you've done. If you don't do that, then you won't be able to share with what you've done. It's almost like you didn't do it at all. All right, so now let me stop sharing this screen and I'm going to go back to my other screen here. And we're going to do a quick recap of what we did today. So today's field trip was about properties of water. During this virtual field trip, students discovered that the natural world includes earth materials. Students observed and described physical properties of natural sources of water, including color and clarity. So we started off by exploring natural sources of water with Miss Nash. Next, we looked at color and clarity of water with Mr. Monroe. Then you saw the egg investigation with Dr. Gorman, and I just completed the drops of water investigation. Thank you so much for joining us this morning. We appreciate you taking the time to learn about properties of water with us. We'd like to know what you think about this morning's field trip, and you can let us know by going to www.tiny.cc/EEC feedback and filling out a short feedback form for us. We hope to see you again during the next field trip for pre-kindergarten and kindergarten students coming up, I believe, in February. Have a great rest of your day, and we'll see you next time. Goodbye.